All right, this review question reads, a fairground ride consists of 4 carriages connected to a central vertical pole as shown in the following view from above. So it's a top-down view and it's not to scale. A motor rotates the central pole about its axis. This results in the 4 carriages each moving along a circular path. The distance from the middle of each carriage to the center of the pole is 3.20 meters. When they are moving, each carriage experiences an air resistance force of 85.0 newtons. Assume that there are no other significant resistive forces. Which torque does the motor need to apply to the pole to keep the system rotating at constant maximum speed? All right, everybody gets a head start before I start putting my working down, and we'll compare notes in just a moment. Is this the, what ride is this? The Sizzler? Is it just like the swings that just kind of go around like that? Carriages. No, the Sizzler also has like I think there's another spinny guy on it, right? Like it's free to sort of rotate about. Or no, I'm thinking of the teacups. I guess that really doesn't matter. All right. Let's go over this one together here. If the resistive force is 85 newtons, that's like this thing is rotating this way, and as it crashes through air, the air is working against it at 85 newtons. But there's torque being generated here, and so this thing is able to sort of overcome those 85 newtons of resistive force, right, by supplying enough force. So we can just kind of say like the resistive force must be equal to the force that the sort of provided by the torque of this pole here. Otherwise, it wouldn't be able to move. So the force given as the resistive force is the force that's sort of being generated by the pole, right? So that's this. And they give us that the distance from the pivot to the carriage is 3.2 meters. And so we calculate 85 times 3.2 is 272. And if you're so satisfied with your answer right here that you choose choice B, you have done all that for nothing, because B is not the correct answer to this. We need to read the question very carefully and go, which torque does the motor need to apply to the pole to keep the system rotating at constant maximum speed? And my system includes not one carriage, but 4 carriages. And so we need to rewrite this calculation 3 more times over here and then add them up. Unless you can think of a better way of doing it. There's not. It's like there's an episode of The Simpsons where they come back from the North Pole. It's the episode. It's kind of a parody of Citizen Kane, Orson Welles' Citizen Kane, and Mr. Burns has a bear, Bobo. Okay, and they find Bobo was like up in the North Pole, and they come back to the Quickie Mart, and they're like, they're all in these like sweaters and things like that, and they're like, We've got to think of a better way to get ice. We lost 3 men on this expedition, like they're mining ice from the North Pole, bringing back bags of ice so they could sell it, at the store. And that's who says, if you can think of a better way to make ice, I'd like to hear it. And like, oh, yeah, got us there. No way to do that. But in one of those bags of ice, what's Bobo, Burns' long lost bear, very similar to Rosebud, Citizen Kane. I'm not going to ruin it if you haven't seen it yet. Some people say it's the best movie ever made. I tend to disagree with that, but it's a matter of opinion. And so anyway, you got to multiply that by 4, right? That is the easier way. Freeze the water, okay? You don't got to go mining out of the North Pole. Come on, we lost 3 men on this. So choice D, right? You multiply that by 4, it's 1088. So once again, don't fret when 1088 isn't up there. That's the same thing as 1090 when you deal with the significant digits. Now, hopefully, when I click on this button over here and I look up 12, it says D. It does. You already looked it up. Good. All right, so that one is D. Yeah, I mean, think about it like this, that the torque is provided, it has to move all of them, right? The system of carriages, or the system, which includes 4 carriages. And so this word right here is really the clue of, you can't just multiply these 2 numbers and get the answer. You've got to multiply them and then multiply by the number of carriages that each needs that amount of torque to move. Okay, it's a system of 4 carriages. And that's why the right answer is B.